Proxima b is an Earth-sized exoplanet orbiting Proxima Centauri, the closest star to our solar system, just 4.24 light-years away. This planet has drawn intense attention due to its bizarre nature, especially its tidal locking. One side of the planet is always in sunlight, burning in heat, while the other remains a frozen world in total darkness. The James Webb Space Telescope, JWST, detected structured infrared emissions on the dark side of Proxima b. These emissions pulse with mathematical precision, causing debates over whether they're natural or artificial. Interestingly, these emissions form geometric shapes resembling urban grids found on Earth. Despite being only 1/1000th as bright as the lit side, they emit terahertz radiation, used in advanced communication systems. 12 zones have been mapped, each pulsing every 27.3 hours, which is identical to Proxima b's orbital period. This strange synchronization makes some believe the patterns are intelligent in origin. However, some scientists argue that crystals in the crust might produce these effects via pyroelectricity. The planet's molten iron core, heated by tidal forces, might power geothermal systems under the ice. If hydrothermal vents exist, they might support extremophile organisms like those found on Earth. JWST discovered ammonia and hydrogen sulfide near emission points, chemicals often linked to microbial life. Yet, the power levels, equal to 10,000 nuclear power plants, seem too massive to be naturally made. The atmosphere of Proxima b is thin, just 0.1% the density of Earth's, making heat retention hard. Still, JWST found titanium dioxide nanoparticles in the icy ground, used on Earth to reflect solar energy. These particles might be engineered to trap heat, forming microclimates under the surface. An advanced civilization could use these materials to create domes or arcologies below the ice. These domes might use superconductors to move energy from power plants to distant settlements. The line between day and night on Proxima b, called the Terminator Line, shows glacier movement. This hints at liquid water underneath, possibly warmed by radioactive isotopes like uranium-238. Such water might sustain a bioluminescent ecosystem, similar to Antarctica's bloodfalls on Earth. Life there could use sound or magnetic fields to move, evolving far differently from light-dependent Earth species. But Proxima Centauri often releases violent flares, blasting Proxima b with X-rays and UV radiation. Living on the surface would require radiation-proof technology or underground shelters. A civilization might hide in lava tubes, using fusion reactors powered by deuterium from comets. The emissions even resemble fiber optic networks, hinting at data systems or quantum communication. If true, this could revolutionize our understanding of physics and communication. The Breakthrough Starshot mission plans to send tiny probes to Proxima b using laser propulsion. These gram-scale spacecraft could arrive in 20 years and scan the planet at centimeter resolution. Such probes might send back images of alien buildings or technological constructs. But space travel has risks. Interstellar dust and cosmic rays can damage these tiny explorers. Scientists are working on self-healing nanomaterials to protect them during the journey. If intelligent life is confirmed, global policies would face radical change and new ethics. The United Nations Office for Outer Space Affairs, UNOSA, has created protocols for first contact. These focus on transparency and avoiding interference, ensuring peaceful discovery. Some theologians wonder if aliens would have souls, while economists dream of unlimited energy. Seasonal methane plumes on Proxima b add more mystery. On Earth, methane links to farming or fuel. But on Proxima b, this methane has no biological markers, suggesting something else is at play. One theory says it comes from methanogenic bacteria, another says it's from factories making fuel. The timing of the plumes matches the infrared pulses, possibly linking them in a connected system. Maybe it's part of a carbon capture project or terraforming experiment happening underground. Proxima B's magnetic field is weak, 100 times less than Earth's, offering little protection from space radiation. Even so, JWST saw auroras on the dark side, glowing green from oxygen ions. This could mean artificial atmospheric repair, maybe splitting ice into hydrogen and oxygen for air and fuel. The planet's surface pressure is like Mars, making big structures hard to build without special materials. Still, using 3D printed regolith and aerogels might allow humans, or aliens, to build stable homes. If life on Proxima b has achieved room temperature superconductivity, it might levitate buildings using quantum effects. That would show knowledge far beyond ours, proving a level of science centuries ahead of Earth. Even if there are no aliens, these events redefine planetary science and natural possibilities. The dark side could have ice volcanoes, or even dark matter reactions, releasing energy in unknown ways. Each theory pushes science to rethink physics, chemistry, and biology in totally new directions. Proxima b might not just be a planet, it could be a cosmic turning point in our quest for understanding. It reminds us that even in darkness, mysteries await that can inspire wonder and discovery. It's a reminder that the universe is bigger, stranger, and more exciting than we ever expected. Subscribe to our channel and thanks for watching.